Want some of this? Then you know what to do, dog. Bust a move.
Welcome to the notes on 6-7. We're going to talk about inverses, both relations and functions, and what they are and how to find them and all that kind of stuff. This is new. So glad you're watching it. Do me a favor and tweet the video or like the video or something. Share the video with your friends so that enough people watch this so that everybody knows what they're doing. All right, so if a relation pairs elements A of its domain to elements B of its range, the inverse relationship pairs B with A just in the other order. So if AB is an ordered pair, then BA is an ordered pair of the inverse. Very simple at the beginning, okay? Very, very, very simple. The inverse relation is just the X and Y switching places, okay? The input and output switching places. Big key to understand that while one of them may be a function, the other one may not be. So just the inverse of a function doesn't always have to be a function. If you remind yourself back here in your Algebra 1 days of what a mapping is, we noticed that right here the relation R is a function because each X has exactly one Y, but the inverse of R is not because there are the 1, for example, repeats itself. Okay, so really simply looking at problem 1, what's the inverse of relation S? Okay, and all we do is switch the X's and the Y's. That's it. Okay, really, really simple here at the beginning. Just switching the X's and Y's takes us from an inverse, it takes us from a relation or a function to its inverse. Same here. If we look at these, if we were given a graph and we were to look at its points, if 0, 1 is a point, well, or sorry, 0, 1, negative 1 is a point, well then negative 1, 0 is a point. So that's how each of these points were gained right here. You'll notice that these points are just being reflected, if you remember from geometry, in the line y equals x. So this is the inverse of relation S. Okay. Take a look at this one. What are the graphs of t and its inverse? Is t a function? Is the inverse of t a function? Please explain. Okay, go ahead and try that now. I'm fine if you graph it. I'm fine if you make a table. Just some way for you to show the relation and its inverse. Okay, go ahead and pause the video and try that now. All right, so you've unpaused. I wrote out the points of the inverse. I graphed the original in red, the original relation, and then its inverse here in purple. So that's what it looks like as a graph. This is what it would look like as a table with really messy handwriting. And then is t a function? Well, t is a function. Okay, so t is a function. Okay. And really simply, it passes the vertical line test. For every x, it has exactly one y, however you want to think of it. The inverse is not. Okay, the inverse isn't. And hopefully you can see, I mean, right here, boom, fails the vertical line test right away. Okay. As shown in problem 1, the graphs of a relation and its inverse are the reflections of each other in line y equals x. That's what we talked about right here. If you describe a relation or function by an equation in x and y, you can switch x and y to get an equation for the inverse. So here's what that means. Find an equation for the inverse of this. So here's what we do. If this is the original, all I do is I switch x with y, and then we solve for y. Okay? We solve for y, and that's it. So we switched x and y, we added y to both sides, square root of both sides, and so the inverse function of y equals x squared minus 1 is plus or minus the square root of x plus 1 equals y. And that's a relation, not a function. Okay? Let's take a look at got it 2. See if you can find the inverse of y equals 2x plus 8. Y equals 2x plus 8. Find the inverse of that. Go ahead and pause the video and try that now. All right, you've unpaused. Let's take a look at the answer for that. Got it number 2 is y equals 1/2 x minus 4. All right, that is the inverse of that function. Okay, if you didn't get that, go ahead and pause the video. Try it again. Remember, switch y with x, so make it x equals 2y plus 8, and then solve for y, and that should help you get this as your answer. Graphing a relation and its inverse, we've done all sorts of graphing. Okay, so this is just another example of can you graph what you're supposed to. We're actually going to graph the graphs of y equals 2x plus 8, which is what we just did. We're going to graph that and its inverse. So go ahead and pause the video right now. Graph y equals 2x plus 8 and its inverse. Go ahead and pause the video now. All right, you've unpaused. Let's take a look. So in red, we have the original. In purple, we have the inverse. In this case, they are both functions. You can probably also see in this case, they both, here, let me make this a little bigger. You can see, again, they're reflections in the line y equals x. So if you kind of tilt your head, you can see that the purple is a reflection of the red in the line y equals x. Okay, if you're tilting your head, that's funny. So the inverse of a function is denoted by f and then this little -1. That is not an exponent, okay? We read this as the inverse of f, or as f inverse. So the notation f of x is used for functions, but the relation inverse of f may not even be a function. So finding an inverse function, let's look at what we do. Again, what are the domain and range? We're going to take a look at this. The radicand cannot be negative, so the numbers x is greater than 2 make up the domain. The principal square root is non-negative, so the numbers y is greater than or equal to 0 make up the range. So that's the domain and range of the function. Then what's the inverse of that? So we replace f of x with y, and then we're going to switch x and y, and then we're going to solve for y. So we get the inverse of f of x is x squared plus 2 as long as x is greater than 0. Okay? That's it. All right? Domain and range. Here, part B shows the domain of the inverse is the range of f. So the numbers x is greater than 0. Since x squared is greater than 0, x squared plus 2 is greater than or equal to 2. Therefore, the numbers y is greater than or equal to 2 make up the range of the inverse. Note that the range of the inverse function is the same as the domain of the original. Okay? So the range is here, the domain is here. They're just switched, just like we switched them to find them. Okay? Now, is it a function? Is the inverse a function? For each x in the domain, there's only one value in the range, so yes, this is a function. All right, you could also look at it by a picture and tell from a picture. This is a quadratic and a radical. Let's take a look at something a little bit simpler. Let g of x equal 6 minus 4x. What's the domain and range for g? What's the inverse of g? What's the domain and range of the inverse? And is the inverse of g a function? Please explain. Go ahead and pause the video right here. Get some answers to 4. Go ahead and pause the video now. All right, you have unpaused. The domain and range, all reals. They're both all reals. Okay, it's a line, so hopefully you got that. For B, the g, and this is like a little -1, the inverse of g of x, and again, it's not an exponent. I can't stress that enough. It's not an exponent. Equals -1/4 x plus 3/2. Okay? If you didn't get that, try again. Again, remember, the steps to that right here. We make this y equals 6 minus 4x. We switch x and y, and then we solve for y, and you can do the rest. Part C, what is the domain and range? Again, this is a line. It's an uglier, different line, or however you want to think of it. It's still all reals for both. And is it a function? And the answer to that is yes, because it's a line for each x. There's exactly one line. All right. Functions that model real-world behavior are often expressed as formulas with meaningful variables like a and r, for that's the area of a circle. Strictly speaking, the inverse formula would be r equals pi a squared, but this expresses a false relationship between area and radius. It's better to leave the variables in place, solve for r as a function of a. Okay, so here's the original formula, and here's the same formula but inversely expressed. We can't take the inverse function of area because this right here is not true. But we can inversely express them just by solving for r. So finding the inverse of a formula, the function d equals 4.9 t squared represents distance d in meters that an object falls in t seconds due to Earth's gravity. Okay, we're going to find the inverse of this function. How long in seconds does it take for the cliff diver shown to reach the water below? So we want to solve for t, so we get t by itself. So we divide by 4.9, take the square root of both sides, and t equals the square root of d over 4.9. Then, this is 24 meters, so we substitute 24 in. We use a calculator, and we get about 2.2. Right? This function here, d equals v squared over 19.6, relates the distance in meters that an object has fallen to its velocity v in meters per second. Find the inverse of this function. What is the velocity of the cliff diver in meters per second as he enters the water? So, what's his velocity now? All right, so we're going to solve for v. Well, you're going to solve for v. You go ahead and try this. You're going to solve for v, and then you're going to plug in 24 for the d. Okay, so solve for v, and then plug in 24 for the distance. Go ahead and pause the video and do that now. All right, you've unpaused. Hopefully you got that v is equal to the square root of d over, thank you, 19.6d, okay? And then when you plug in the 24 for the distance, we get about 21.7 meters per second, okay? If you didn't get that, pause it, try again. If you still don't get it, let me know, and we'll work on it. You know that for any function f, each x value in the domain corresponds to exactly one y value in the range. For a one-to-one function, it is also true that each y value in the range corresponds to exactly one x value in the domain. A one-to-one function f has an inverse, f inverse, that is also a function. If f maps to a to b, then the inverse must map b to a. Okay? The key concept here is that if f and the inverse of f are both functions, then the domains and that everything works still. The inverse here, we're going to look at composites. That if we have the inverse of f of x equals x, and if f of the inverse of x equals x for x in the domain of f and the inverse respectively. Yikes. Okay, so this, that's a mess. We're going to look at what that means exactly. But it's a big concept. We're going to talk about composite of inverse functions. Okay. So for f of x equals 1 over x minus 1, what is each of the following? What's the inverse? And then what is it when we plug 1 in? Okay, and we do a composite. All right. So here's what we have. Let's take a look first at what's the inverse. So we switch x and y, we solve, and we get this. So our original function is here, our inverse is here. All right, so far so good. Now, we want to put 1 in as a composite. So first we're going to put 1 in the inverse, and we get 1 over 1 plus 1, which is 2. Then we're going to put that 2 back into the original, and we get 1 over 2 minus 1, which is 1. Okay? So this is 1. When we do it in the opposite direction, we get 1 over 0, which does not exist. Therefore, the composite, in this case, does not exist. All right? Yikes. So find the inverse and then do some math. So for got it number 6, you're going to find first just what's the inverse of g of x. Then on part B, you're going to find it by replacing 0 in this order. And then part C, you're going to do it in this order and see what you get. Go ahead and pause the video and try that now. All right. Hopefully for A, you got the inverse of g of x is 4 minus 2x over x. Okay. B, 0 is not in the domain. Okay. This, hopefully you got something with a 0 in the denominator. It doesn't exist. When we plug 0 in right here, you should see right away that's a 0. It's not going to work. When we plug 0 into the original, okay, and then into the inverse, we get 0. Okay, we get 0 because we end up with 2, and then 4 minus 2 is 4 minus 2 times 2 is 0 up top and 2 on the bottom, so this one is 0. This can be complicated, guys. I promise it's just about doing simple things in the correct order. That's it for the notes. If you have questions, make sure you write them down and we'll go over them. This video, like I said in class, if you don't watch it, you're going to be really lost. So please watch it, share it, like it, tweet it, retweet it, complain about it, do whatever you have to do so that people are watching the video. I will see you next time. Bye.